these might be good things to put on your note card. The packet that you guys have, the one that's stapled, that's what's due on exam day. So it says my exam is on, and we can add to that. So your guys' exam is on Friday at the normal time.
What's the normal time?
Oh, exactly. So that's Friday's exam. Now Thursday, I technically don't see you unless you're coming for a study session. So we have that study session before the exam starts. So Thursday we don't have regular algebra class. So I have you guys today and tomorrow, and then Friday for the exam. Now for the exam, if you finish early, you still have to be here. So if you know that you can't keep yourself or you obviously won't have any homework to do, so find something to bring, like if it's reading or even
jump on the stalls and
okay, good. Even if it's playing a game on your computer at that point, that's fine. So just that you're not distracting other students. But yeah, so our exam is on Friday. When you guys come on Friday, I ask that either on Friday or before, you guys bring your textbook back if you guys have one. And if you're unsure, I do have a list of who has textbooks. We signed them out to you. That day you want to bring your note card. And you want to bring your review and any missing work. That morning is the deadline for getting stuff in. And the fact that we test Friday gives you guys an extra day over my algebra, who typically is, after you guys. So my algebra in third hour. So you guys want to bring a calculator with you. Don't bang on the fact that there'll be enough calculators. Oops. Trying to think of other things. On that day, don't forget your laptop. You guys will be turning that in along with other stuff that you guys have checked out. So bring library books, stuff like that. All right, so we're going to flip back to our note sheet, and we'll kind of go through these today and talk about the different rules that we talked about in these chapters. The whole back side is what we just tested on. So I don't know if we need to spend, well, I guess we can still go through all that. But that's the most recent stuff. The front side is the stuff that's been a while ago. So I hope to do this whole page today, and then tomorrow we can review chapter 6, which I mistakenly forgot. So I remember a couple weeks ago talking with a student about that she had asked about how long, what other chapters we've covered. And I said all the way back to chapter 6, but I think this chapter was chapter 6 in a previous book I taught out of, so I had myself all confused. So yeah, there's the schedule if you guys need it, and then we have a note card. You guys can use both sides of this half sheet of paper. Now, if for some reason you lose this sheet, you can use any sheet of paper that's the same size, and just half of it you can use both sides. So you don't need the cardstock. I just have that so it's maybe easier to find just a different color than your other stuff. So they want us to solve by graphing here. So one of the things to remember with solving by graphing is we want to have both equations in slope-intercept form. And remember, with solving by graphing, we're looking to see where the two lines cross. So the first equation's already in slope-intercept form. So where are we beginning? Where do we begin that line? At 6. So this is our beginning. So this is where we begin at 6 on the y-axis. And then for my slope, I'm going to do 2 over 1. So up 2 over 1. So we should have our line going there, hopefully. Hopefully yours is a little bit better than mine. So there's our first line. Now the second equation is a little bit tougher because that one, the y is not all alone. So I need to get y alone in order to graph that one correctly. So what are you guys going to move in that second equation? I'm going to get the y alone, so we're going to move that negative x. So we're going to add x. So this one, I'm a little worried I might have set this up wrong and it doesn't work nicely. We'll see how it goes. I don't know, do these cross nicely? Begins at 3. And then we have to go up 1 over 1. And then down 1, back 1. Oh yeah, it does fit. Sorry, my big dots are a little distracting. So they do cross. They cross right on that x-axis. So the solution for that will be where they cross, which is, negative 3, 0. So that's the answer for this graph, or this set of system of equations. So there's some like this obviously on your review, so if you forgot how to do that, this is kind of a reminder of those, and hopefully kind of jogs your memory there. The next one is to solve by substitution, and that's where we replace one variable with an expression. So if you look, this says x equals this. So instead of x, I'm going to put that there. This one has some big numbers, or it's going to end up with some big numbers. So in place of x, I'm going to replace it with this negative 3y minus 56. So I rewrote my new equation with my x gone and my y being, or my x being replaced, and now we only have y's. So I distributed. Then I have some like terms I can put together. So this negative 6y and negative y is going to be a negative 7y. I'm going to move this 112 over. And then to get my y alone, I have to divide by a negative 7. And I think that's negative 16. I don't know if anyone else did that. Is that right? Sometimes my division in my head is not so good. And right. So y is negative 16. Once I know that, then I have to substitute that back in to find our x. So I'm going to put it back into this one. So I have x equals negative 3 times y, which is a negative 16, minus 56. And I believe that's going to be 48 minus 56. And so x ends up being a negative 8, I believe. So that's substitution. That's where you replace one variable with the other expression. The next one is elimination. situation is the one where we want something to cancel when we add the equations together. If I added the equations the way they are, nothing would cancel. X and 5x would be 6x, y and 7y would be 8y. So nothing would cancel with the variables. So this is one where I may have to multiply by something first to make something cancel. Anyone remember what we need to do here? What can we multiply by, bless you, to make something cancel?
Either 5 or 7.
5 or 7, probably a negative, right? I would probably choose 5, just a little bit smaller number. So we're going to multiply by a negative 5 because then those x's would cancel. So it gives us opposite values there. So I multiplied that whole equation by negative 5, including that negative 3 over there. That's where that 15 came from. Now these two equations can be added together, and the x's will just cancel. So 7y minus 5y is 2y. This is 6. So to get my y alone, now I just have this easy one-step equation to solve. So we find out y is 3. Once I know what y is, then I have to substitute it back in to find x. And I can put it back into either of the two equations. I typically choose what I consider like the easier one. I think this second one would be easier, or the first one, sorry, that's the first. Opposite day. So I put that 3 back in for my y, and then I just move this over, so I find out x is going to be negative 6. So if you guys recall, these systems of equations, we're solving for x and y.
Mrs. Johnny, do you like Frozen?
Did I start with the movie Frozen?
Yeah.
Yes. I like Olaf a lot. And what's the elf's name? Is he an elf?
So reindeer?
Sven, reindeer. Yeah.
That's not a reindeer.
He's a reindeer.
Reindeer are usually littler. He's big.
He is a reindeer, isn't he?
Right. What's his name?
Is he Sven? Or is that
That's both of them. Sven and Sven.
What's the guy's name though? That he's also Sven?
Yeah.
Oh.
You know, he's the songs of reindeer.
Oh. See, I haven't seen that many times. Yeah, she feels strongly. Okay.
Yeah, it's Sven.
Oh, I somehow missed that.
Yeah, because Olaf kept asking me.
It's not a reindeer, it's an elf.
Like Sven. Well, what's the other?
Yeah.
It's Sven.
Google said he's an elf.
I like the summer song, like when Olaf sings about summer.
That's a very obvious choice.
Tyler.
Okay.
Google said he's an elf.
Don't talk to my mom like that.
It says it in the movie.
Are elk and reindeer the same thing?
No.
Clearly no.
I'm literally angry. I can even say this from experience because there was supposed to be a whole musical thing. I was going to be.
It's not a reindeer.
Oh, the musical, like before COVID, right?
Yeah. I was super excited. I got to be filmed.
It is a
It's
reindeer.
not a reindeer.
Anyway, he is a
It's not a
reindeer.
reindeer.
Hello.
Never seen a reindeer.
Which is the Disney Incorporated thing.
And after the weekend too.
Who cares?
Shut up.
Oh, no, I think I
He's a reindeer.
Oh.
Ow.
Okay, guys, let's do this problem together. I have them up here. I have our notes up here. And I don't think they're online yet. I'll fix that. I'm a little slow.
Can you stop saying you're recording?
Yeah, I'm recording.
Is that what you're recording?
Yeah.
You stared at that for a very long time, making sure that you were
Okay.
actually recording.
All right. So, guys, this system. If you guys recall, graphing systems with these. This is where we have to remember. There's either a dotted versus solid line. then we also shade. What's it? Oh. Yeah. So where are we going to begin this first equation? No, yesterday we did the retake.
Oh shoot, that's right. Okay.
And then this is they got this though yesterday, but just, this is supposed to be chapter 7. I missed chapter 6. There's all sorts of, I had issues. All right. So we're going to begin this at 0 because there's no b in this case. And then we go down 2 over 1. Remember slope dude going downhill. We're going to talk about slope dude recently. And then up to back 1. And then this one's going to be, is that solid or dotted line? So a dotted line. But remember, we also need to shade on these. Now I picked this one intentionally because we can't pick 0, 0 to test because it's right on the line. So we're going to test something other than 0, 0. We're going to test 1, 1. 1, 1 is right there. We can test that and check and see in the equation if it works. So 1, 1, we're putting 1 in for y and for x. So I put it in for y and x. 1 is greater than -2. That's true. So we're going to shade the side of the line that has 1, 1 on it. So grab my highlighter here, and I'm shading up here. Oh gosh.
Is it not going wrong?
But now we have to graph that other line as well. So this one, x equals -4. You guys remember what kind of line x equals is?
It's a straight line.
Straight line, which way? X equals up and down. So x equals -4 is a vertical line, y equals would be flat. So I go to -4, and I'm going to draw a solid line. Now this one, I don't really feel like you have to test, you can test 0, 0. I can kind of just read it, it makes sense to me. But 0 is greater than -4. That's true, so I'm going to shade the side of the line that has 0 on it. Which happens to be this way. Whoops. I messed it up. So over here. And so the solutions are where the overlapping green is. So where they cross together. So all the solutions show up in that green section there. All right, so when you're ready, we're going to look at our exponent rules next. The exponent rules, you guys, we made a chart for the exponent rules. I think it might have been on blue paper. So I try to put those on colored paper so you guys can remember or can find them more easily. Yeah, so it was like on blue paper. We made a chart with exponent rules. This would be a great thing for your note card that I would put on my note card if I were you, all our different exponent rules. Now, if for some reason you don't have this, the reason why I save my board, I always save the board, like it is saved in my files when you guys make fun of me for having lots of files, this is why. I save it, so if you're ever like, I lost that or whatever, I can always send you an email with it. Just let me know, like, or you can send me an email. So that would be a great chart to like reference as we're going through this section. So I even made a little note to you guys that there's a chart for that. Also, it should be online, but you'd have to watch the video then. So our chart is blue. so our exponent rules with multiplying and dividing. So it starts a little more basic, gets a little more complicated. The big thing to remember with our exponent rules is the coefficients are just regular numbers. So treat the coefficients, the big numbers, like normal numbers. So whoa, yikes. I have like calligraphy pen on. Didn't mean to do that.
That's fun.
It is fun. I could do it, just make it smaller. So 2 times 5, we actually multiply those. So that ends up being 10. And then I have my x to the third and x squared. But those we add the exponents. So that's going to be x to the 5th, right? It's pretty. Calligraphy. So you multiply the base or the coefficients, add the exponents. Now this next one, the 4 over 6, you want to treat that like a normal number. 4 over 6, we just want to simplify. So you don't do 4 minus 6, you're going to simplify 4 over 6. What can I divide them by? They can both be divided by 2. So this becomes 2 over 3. And then this is where I ask that question, where are there more m's? On the bottom, how many more? There's 1 up here and then 4 down there, so there's going to be m to the third on the bottom. Okay. Then going down to the next one, this one involves negative exponents and 0 exponents. So remember, we want to move exponents if they have a 0 or we want to move bases and exponents that are negative. So if there's not currently a fraction, I might want to make one. Everything's currently on top. Does the negative 5 need to move? No, negative 5 can stay. Negative numbers are fine. It's negative exponents we don't like. How about x to the 0? What happens with that? Do you guys remember? It just cancels out. It just becomes a 1, so that's gone. And then y to the negative 2. In order to make it positive, we're going to move it in the fraction. We're going to put it on the bottom. So it's going to be a y to the second. All right, the last one here is power to a power. It has division. It has a whole bunch of stuff going on. I would really like to simplify inside first before I work with that second power on the outside. So, is 3 okay? Yeah. Where are there more x's? On top, how many more?
1.
Yeah, 4 minus 3 is just 1, so x to the first. This y to the, oh, I need to put a little 2 out here so I don't forget about it. This y to the negative 1 is going to move to the bottom and be with the y to the 5th. So if you kind of picture what's happening, I have both of those now on the bottom. Whoops. They're both on the bottom now. So that's going to be y to the 6th on the bottom. Okay. You okay with that so far? Okay. Now that second power has to be distributed in everywhere. So this becomes 3 to the second, x to the second, and then y power to a power we multiply. So y to the 12th. And the only thing left to do is that 3 to the second, I'd like to simplify that. So I'm just going to make that a 9 there. Okay, so then this is it. All right, we'll finish up with just talking about scientific notation a little bit. So just remembering that scientific notation is that when we have positive exponents, it's a really big number. So like 1.2 times 10 to the 5th, it's going to get really big. And then if it's a really small number, we write it with a negative exponent. So this one, I got to move it 3 times. Remember, we talked about it being like lunch money, concession stand money. And this is going to be a negative 3 here. Just kind of remembering those with scientific notation. And just one more thing to mention. I think I put these on our review. I don't think we did a ton with this.
I think so.
But yeah, give you a couple of values. So like if x is -4, and I want you guys to evaluate x to the 3rd power, that just means you put -4 in and raise it to the 3rd power. So in your calculator, you probably want to use parentheses, so it just means -4 times -4 times -4, which is going to be a -64. So there's a couple of those on the review. Okay, so we'll stop here for now. We can take a little break, go for a little jaunt.